Hi everyone, this is just a quick instructional video for Physics Lab 2.3.3 on thermodynamics. So it's important that you read through the materials for this lab because the dry lab requires you to think about how you would perform the experiment if you were actually in the lab. So first start by reading through the materials that were used to collect the data. And then take a look at the rubric down here. This is the rubric that is used to score your lab so you know where the points lie, okay? 20 points for procedure, 10 points for analysis, 6 points for your conclusion, and 14 points for your exploring further. Today we are looking at the dry lab for thermodynamics. So dry lab. And what you will see here, again, the materials, the procedures are here. So it's important that you're reading through the procedures. There is an equation that you're going to use. It's right here, Q equals mc delta T, okay? So M stands for the mass of water. C is the specific heat of water, which is given to you here, 4.18 joules per gram degree Celsius. And delta T is the change in temperature of your water, okay? You are going to be first recording your prediction in data table 1. So again, continue reading through the lab. What did they do? How did they collect the data? I'm not going to read through this for you. I think you can do it all on your own. When you get to your lab table, your data table, what you're doing is you're making a prediction on the temperature of the water after it's mixed. Okay, so this is the hot water, this is the cold water. After you mix the water, what is the predicted temperature and how does that compare with the actual temperature? Okay. In part 2, you are looking at heat transfer from a solid to a liquid. Okay. So again, reading through the procedures, you are given here some specific heats for substances that are other than water. So aluminum is 0.899, copper is 0.385. Remember, waters was very high compared to those numbers. Waters was 4.18, okay? So compared to some of these values, water has a very, very high specific heat. That means it can retain a lot of heat. It can absorb a lot of heat before its temperature changes. That's what specific heat means. How much heat can you hold before your temperature has to change? Okay. Data table 2, again, you're making a prediction of the temperature here and then comparing it with the temperature that was actually achieved. Heat transfer from a solid to a gas. This is, again, some procedures that you're going to read through. Specific heat capacity of air, so this is the C in mc delta T, for air is 1, okay? And then the analysis questions, what happened to the temperature of the cold water when you mixed it with the warm water? What happened to the cold water when you placed the warm metal block in it? How did you calculate the final temperature? Okay, these are easy questions. How did you calculate the final temperature, or how did you calculate a final temperature compare? These are compare questions. Compare to the actual temperature of the water-metal mixture. And how did your calculated final temperature compare with the actual temperature of the air-metal mixture? So this is water-water, solid or water-metal, and air-metal. All right, and then your conclusion questions. During the experiment with the hot metal block in cold water, in which direction did the thermal energy flow? From what to what? Did it go from the metal to the water or from the water to the metal? Okay. In which direction did the thermal energy flow in the metal to air? So tell me, did it go from metal to air or air to metal? And what method did the energy flow through? This is just identifying the variables that affected the final temperature. And then how would you create an efficient system of heat transfer? So after you've identified what variables were affecting the final temperature, you want to think about how can you minimize the error within those variables to get a more efficient system. And then you're exploring further. So the first question says, what is the unknown variable in part 2? In which the warmed metal block and the cooler water are combined. How would you determine its value using the more advanced features of spreadsheet? Okay, so hopefully you know something about Google Sheets. What is the unknown variable in part 3? There are multiple questions here, guys. How could you determine its value? How could you use the more advanced features of database software to determine if the experimental value is accurate? So talk about percent error and error analysis there. And then you're going to design an experiment to test the movement of thermal energy by radiation. So by doing that, you're going to list the materials, the equipment. Again, you're not doing this experiment. You're just telling me what would you do, how would you do the experiment, and summarize your procedure. Use a creative verbal technique such as an oral presentation to effectively and persuasively answer the following questions. You can just type the answer to this question. You don't have to do a presentation. So you can just type it out. Okay, I hope this is helpful. If you have questions, you don't understand how to answer something, shoot me an email. I'm happy to jump on Zoom and help you out. Okay? Have a great day.